Right, okay, now the next slide says that the power gain. So we need to define some characteristics for the power amplifier. The first one is power gain. Now it says that a power amplifier delivers power to the load. This is the main objective of our amplifier, to deliver power to a load. The power gain of amplifier is the ratio of the output power, right, the power delivered to the load, to the input power, right, given by this formula. So we can see that over here it is a ratio of two powers, power delivered to the load and the input power to the amplifier. So by definition, okay, uh, we can see that, okay, how power is defined. Power is defined as V square divided by R, or it is also defined as I square R. Remember that in terms of current, I can also say this is I square R. Okay, so remember this is I, so this is I. Okay, now over here, since the AC power, we express the voltage in RMS, okay, which is the root mean square. Okay, so we can define the power load, okay, the power delivered to the load by this equation, which is equal to V square divided by R, but I'll put this L subscript to denote the power to the load. Similarly, I can define this Pin, okay, by V square or R, V square or R, okay, and then putting subscript which is In to denote that this is input power. So it means that the amplifier looks like this, right? Remember, this is like a sort of, this is amplifier, okay, this inside, this is amplifier, right, in the box. Okay, this is the resistor, this is the source, you can see this is the source, this is the ground, I can call it, this is ground, this is the V in, right, okay, this is V in, and this is the load. Okay, so basically this is something, the RL, we can call this RL, and we can call this RS. Okay, and there will be some R inside, right, okay, which is the input resistance of the power amplifier. So basically the ratio of the power drop across this RL, okay, to the input power, okay, given to the amplifier is basically what is your power gain over here. Okay, so this is done. Now the power gain, if I put these two values PL and Pin, okay, in the equation over here, okay, in this equation, so it will be okay, VL square divided by RL and Vn square divided by Rn. So this Rn goes over here, okay, to the top. So remember now, this one VL divided by Vn, okay, the voltage across RL, okay, which is this voltage, okay, this is RL, sorry, VL, okay, this voltage, and to the input voltage we can denote this by voltage gain. Okay, so over here, if I remove over here this, okay, so we can represent this by a voltage gain. Remember this one, okay, so I can put it a voltage gain, it was a square value, that's why this you can see square this, so Rn and RL. So it means that the power gain can be represented, the output to the input or the PL to the input power can be represented by this equation. So if you know Rin of the input resistance of the amplifier, the load resistance, and the gain of the amplifier, so you can put the value, you can find out the power gain. Okay, now as an example, it says the recall from chapter number 6 that for voltage divider biased amplifier, R in total is this. Okay, so if you have a voltage for common emitter, a common collector amplifier, actually this is the R in total, where R in base is given by this formula. So if you have it says then the purpose of this two lines says that if you have an amplifier which is common emitter or common collector, so you can readily uh, calculate its power gain, which is by this equation, by this relation. So RL is known, and you can put the value of the gain. Let's suppose if I say over here, for example, assume a common collector amplifier that has an input resistance of 5 kilo ohms and a load resistance of 100 ohms. I calculate the power gain, right? Okay, so it means that if I have a power amplifier like this, okay, so if I say making a box, okay, if this is connected to a load resistance, right, this is ground, and this load resistance have a value of 5k, right? Okay, and this is right, okay, and what else that it has an input, so this is now this is the load is always is 100 ohms, not this one, okay, is 100 ohms given by this one, right? And the input resistance, okay, the input resistance, and this is a source I can draw, this is our source, this is ground. The input resistance, let's suppose for this network, okay, for this whole network, like we included this RS, and this, let's suppose this amplifier input resistance is given by 100 ohms, 100 ohms, sorry, is given by not 100, by 5 kilo ohms, right, 5 kilo ohms. Now what can I do? I can, so RL over here is 100, so I can get this equation, okay, I can put this 100, RL is 100, right, and this is Rn, okay, we did not do calculate it, it is given, it is 5000 ohms, right, and it is a common collector. This one is a common collector amplifier, this one is a common collector amplifier. So for a common collector amplifier, the voltage is AV is equal to 1. Why a common collector? We have input 8 the base, okay, and output 8 the emitter, okay, for a common collector. So the voltage gain comes out to be 1. So if I calculate this one, so I can say I have 50 power gain. We can take out the log of this, okay. Now this is 10, should be, I should say, no, it is not a voltage, I should say 10 log of, and then this 50. So whatever the value comes out would be your answer. Okay, this is unitless, remember. Okay, this is done.